Hello and welcome back to the lab. Today on the bench we have another HP meter that is destined for the bench. In a previous video we took a look at the 412A, which has a current measurement and no AC, volts, ohms, and current. This is the 410B, and it has no current measurements, but we do have AC. So between the two meters, I can cover most of the needs with some high impedance circuits. This one's a little bit rougher shape than the 412. It's been used a little bit more. I'm going to need to clean this up a bit. Still in really good shape, just needs a bit of cleaning. The probes need some cleaning and things like that, but see if we have anything. This has a calibration exemption on the ohm scales and was last calibrated in '87, so it's been a while. Fortunately on this one we have the Fluke 4200A. I'm sorry, the 5200A, so we'll be able to calibrate the AC without a problem. But first off, we got to get into it. So in this case, the probes are at the bottom. I need to pull this bracket off. Just get in here and pop this off. No, we're still caught. Come out. That's trying. Alright, there we go. Okay. That's fine. We'll get this untangled from... Okay, probes are off the bottom. Now we got to get into the back. So we push the button, pop the door out. Let's see if this one will fit through the line cord. It does. The line cord actually comes off. Cool. So I can get the complete back of the unit out of the way, which will be very good for servicing. These two screws, and it pops off. Judging from the plaque, this might be a late model unit. That would be good. That'd be really nice if this is a late model unit. Let's see what we find. We have stuff and dust. And we'll be cleaning that, that's for sure. Well, it doesn't look too bad. OB2. Oh, that's the ballast tube. We got a 6X4 and two 12AU7s. This cap C10 will get changed. This is a newer unit, late model unit, because on some of these there's a selenium rectifier down there. This one's actually got a diode. So this is a very late model unit. This tag board looks in pretty good shape. This cap for sure needs to be changed, but... And we have insulated, yeah, it's not... Comments floating on that, which is fine. We have a grommet failure on the fuse, so we'll deal with that. That's not a big deal. Yeah, this looks like it's going to be a pretty straightforward restoration. I am going to want to check these 12AU7s for balance in the triodes, because that will cause some issues in the circuit. So we'll throw those on a tube tester as part of this, and then we will run this through an alignment. But this is looking really, really good. I am really happy about this. This is a nice unit. So, cool. Don't have to deal with the selenium rectifier, and we have tubes. So, this one I think is going to be pretty straightforward. Switch cleaning, check some stuff, replace a cap or two, and do an alignment. But time will tell when we get into it. Okay, I have our bulk filter cap replaced. I added this terminal tie strip. It is not going to interfere with any of the adjustment locations. That's fine, and everything is good to go. Given that this is a tube set, and I also need a low capacitance value because this is a vacuum tube rectified, you don't want to overdo the capacitance. You'll blow the bonding wires off the rectifier tube. This is a 4 microfarad at 450 volts. The lowest cap I had was a 10, so we're going to try that. If it has any trouble, that's even kind of pushing it. I really don't want to go much more in capacitance than that for that particular point in circuit. But I'm at the point now where I need to switch the equipment on the bench from this piece of gear to the tube tester. I'm going to pull up the tube tester. We'll get that on the bench, and we will test these two tubes. The important part is not if these triodes test strong or weak or whatever, but that they're balanced with each other because they're dual triode tubes. And the balance is the most important thing. So I'm going to switch out some gear, and then we'll be back with the Stark on the bench. Okay, I have the roll chart set up for a 12AU7, so we are at 12.6 filament volts. We're on EV 7608, 7608. That is correct. So let's pop one of these HP tubes into the tester and see what we look like. We'll do a line, on, line adjust. I'll move you guys off to the side because I need to be in line with the meter. Line adjust. And we're running a little hot, a little light. Give it some more. Oh yeah, tube's glowing. This socket is really, really loose on this tester. I'm going to have to drill out this socket and replace the 9-pin on this particular one very soon. While the tube warms up, we'll set the bias at 24. And then we will set the English at 75. Check the tube for shorts. Momentary flashes are okay. That triode's all right. Check our line voltage. Looks good. And we're looking for a mutual conductance of about 2200. So we should be way up here. And we're going to do... we are at 26, a little bit above 2600. So that is a very strong tube. Or that triode's pretty strong. Let's check the other triode. So what were we at? Actually, that's now reading like 28? Yeah, very good. All right, so we now want 2, 1, 0, 3. And since the tube's already warm, we can check immediately. Not quite as strong, but still very healthy. That one hit about 26. That warmed up very quickly. No shorts. Yeah, that base is not happy. No shorts on that side of the tube. That's about 26. Let's check the other side. 7, 6, 0, 8. Check for shorts. Nope. Line adjust. Hit it. Yeah, both of those tubes are very healthy. That's about 2,700. So, yeah, both of these tubes are in very good shape. My socket is in really rough shape, but the tubes are fine. So, I am happy with that. We have a couple more tube testers for the lab too that I need to rebuild. That will add to the testing capabilities, but those will be in future videos. I will also get this socket replaced. All right, after a surprising amount of mechanical work to get some tape residue off, old masking tape's a pain in the butt to remove, I have, and I've got a surprising amount of equipment on in the lab to bring this thing back to life, or at least give it a good alignment. So we've got the AC calibrator on, the DC calibrator on, the function generator on, both high accuracy DMMs on and warming up, frequency counters on. So we got a decent amount of stuff. So, first thing we're going to do, because I don't need to wait for the device to warm up, the HP to warm up for this, is I need to set the filament voltage in the tube just in case any of my workings bump some things loose or not. It's 6.5 volts for one of the tubes. I have the OC1 tube in this one, so it's 5 volt filament. So I need to set mine for 5 volts. I have it hooked up to the 6500. We're going to kick this to on, and we should see some voltage come up here in a bit. Probably helps if I put in AC volts, because I bet you this is AC. It is! And it's running about 4.3. Okay, so we're at 3.96 right now, so I'm going to dial this up to 5 because we have the lighter tube. Okay, so I'm having some heater voltage problems in the AC probe, and I'm measuring from chassis ground to the AC tube, and I had an intermittent connection, which I have fixed, but I'm still having a heater problem. The intermittent connection was at the tube base. I had to tighten up the ring on the outer side of the tube base to get the heater current, or to get the connection to be good. But I'm still about low half a volt, and I'm also quite low on resistance. So I think the tube is, I think the heater in this tube is having some trouble, and it's not getting hot enough, which is why I'm having AC problems. The ballast tube is out while doing this testing. It usually hangs out about here. Pin 7 on the ballast tube, and it's just a resistance measurement. The manual says it should start at 2 and then slowly climb till it goes up to 4. And mine's hanging around 2.2, so it's not climbing like it's supposed to. I don't see any shorts, like moving the cable and stuff like that. It's not causing me any problems. But yeah, it's not causing me any issues. I was just checking on the AC, see if the reading changed. It did not. But that is my current problem with this unit, so I have a sneaking suspicion it's this tube. I bought 2 spares. That is a pricey tube for what it is. It's like $30. The other thing with this tube is I looked at it, and this might also be a high-hour tube as well. I don't know how well the camera's going to pick this up, but the getter in the tube looks kind of smoked a little bit. So it's not. This might just be a either a gassy or a dead tube. The positive terminals here, negative, or well, it's AC, so it's one of the heater terminals is here. The outside terminal is the barrel. This is the 2-01C tube. I have some of the other ones on the way. The EC53s, if I remember correctly. This is the socket in the probe. Front end grips the inside of the tube. This clamp is on the outside. This is actually one of the signal leads, and the input to the tube is up here. It's capacitively coupled through the tip into the probe, and this is actually a diode. So it's doing the high-frequency AC rectification so the meter can read it correctly. But my general consensus right now is this tube is toast, so I want to be real careful not to lose this spring contact. I'm going to need that for the replacement tube. And as you can see, the meter, when I insert the tube, the meter kind of goes nuts, which is to be expected. But so we don't lose any of the contacts, all that's put back together. And the reason the capacitor saw 300 volts across it when I measured it on the meter was because it is both on the positive, but it's referenced to the negative supply, so it's actually doing double duty. So when that tube gets here, we will continue and see if that's our problem or if we have other issues. These meters are pretty simple to work on, so I'm hoping that's our fault, but I will know here in a couple of days. Okay, well, the tubes came in. We have an Amperex EA53, and I have that in the probe, and I had a bit more learning. The new learning is the probes on these 410Bs are set up for one of 2 tubes. I believe it's a 2-01C and a EA53. The probes are physically different for those 2 probes. Here's the the 01-2C, or the 2-01C. Yeah, 2-01C. And if they're set up for an EA53, you don't get very good contact on the heating the heater of the tube. So this tube may be good, it just may have been in the wrong probe. I could tell when I inserted the new tube in the probe, the fit was infinitely better. It wasn't moving around. It was nice and tight, got good connection, and everything like that. So I am relatively hopeful as to what we're going to find out when we fire this thing up. And we will go from there. Okay, I have the heater, or I have the 6500. I'm warming up the 7510 as well. 6500 hooked up to the DMM, so we can fire it up, see if we get better heater voltage. If we get better heater voltage, we'll check it with a function generator. Let me turn the function generator on. Let it wake up. And then as long as everything's working, I think we're ready to start a calibration on this meter. But I'll have to let it warm up for a while, but I'll go make some coffee in the meantime. So I have it set to AC. We'll drop this down. And we will turn on the unit. We're on 1 volt, the 1 volt range. And we will kick this over to AC. Pilot lights lit up, which is good. I see the filaments in the ballast tube glowing, but now they're cooling off. And that's looking much better already. So on the 2-01C tubes, the heater voltage used to be set at 5 volts. On the EA53s, we need to be at 6.5, which we're very close already. So I'm going to let this warm up and stabilize. And then I'm going to set the heater voltage. And then we'll test the AC range and see what happens. Okay, I've given the unit some time for the warm-ups to happen. And we have had some voltage drop on the heater in the tube. So let's tweak this. 4, 3, 4, 5. I'll do 5.3 volts. Okay. So we'll let that stabilize again while I finish up the coffee. And then if that hangs around at 6.3, 6.2, 6.3, we'll hook up the function generator and see if we have readings that make sense. I'm going to have to kick on the amplifier for, if we do end up getting into a calibration, I'm going to have to kick on the amplifier for the 5200 because the 5200 only goes up to 100 volts and I'm going to need a 300 volt source. So we'll see what happens, but I'm starting to get excited. Okay, it did stabilize a bit high, but I knocked it back down to 6.52. So let's see what AC measurements look like. Okay, I have the function generator hooked up for a 1 volt RMS because this is an RMS meter. 1 volt RMS out of the Regol 4162 into the probe tip from this BNC connection, and then we have ground. So the outer shell of the probe is chassis ground of the meter. So common doesn't even need to be hooked up. This can be common. Now this lead is really important when it comes to high frequency measurements because it's connected like an antenna. If we get meter deflection when I turn the output on, that's a really good sign. There we go, and it's actually set pretty well. Now, this is not an ideal measurement. The meter's on its side. It's not in its case. It's not warmed up. So nowhere near ideal. But that tells me that the probe in the tube is working, which is fantastic. Here's what happens if you note the deflection of the meter here. This is what happens if you put a 1 volt peak-to-peak signal instead of a 1 volt RMS. So if I go to amplitude, actually we go to amplitude and we go to 1 volt peak-to-peak, because this is an RMS meter, we don't get near as much deflection on the meter because we're measuring a 1 volt peak-to-peak signal as opposed to a 1 volt RMS signal now. So in this particular case, units are wildly important. Well, since that's working, let me put it back in the case. I'm going to give it about 20 minutes to warm up, and then we will see if we can do a full alignment on this and get it ready to go for the bench. Okay, we have the meter sitting flat on the bench, back in its case. on the lowest ranges, I need to do it in the case. I am going to have to pull it slightly out of the case to do the higher AC ranges. I think it's 30, 100, 300, and above that for AC volts. But I think, yeah, this only does 300 volts AC. It doesn't do 1,000 volts AC. It does only 1,000 volts on DC, which is fine. Touched up the mechanical zero of the meter. That looks good now. This is so sensitive. Just touching these cables is causing meter deflection. So I'm tweaking the. I am tweaking the zeros, and then I'm going to give it about. The manual says 15 minutes. Probably give it a little bit more than that to finish stabilizing internally, temperature-wise. The case is still cold, and then we'll get on with the calibration. For DC, I believe you calibrate the 1 volt range, and then everything else is calibrated against the 1 volt range. And in AC, you have calibration points for 1 volt, 3 volt, 10 volt, 30, 100, and 300. So you actually calibrate it on every range. And then we'll also touch up the ohms range as well, because this is an incredibly sensitive ohms meter. 500 megohm is what this meter can read. So I do have a need for some very high resistance measurements in the lab, so that 500 megohm range will be incredibly useful. But for now, it's got to make it through a alignment procedure, and when I was doing the meter zeroing, I did have the DC probe grounded. Or, I'm sorry, when I was doing the meter adjustments, I had the DC probe and the common connected. So, everything is working. Everything is looking really good. If we kick this to negative, we shouldn't see much deflection on the meter, and we don't. That should be enough 1 volts to calibrate the 410B. So we'll move that signal down to the 410 and get it adjusted. Not too bad, but we're off by a touch. So we'll need to tweak up the calibration here real quick. I'm going to move the camera off to the side because I need to be straight on when I'm doing this alignment. So here we go. Kind of hard to get this tuning tool in there, but okay, there was problems with my probing method, and there's corrosion on the front of the DC plug. So I need to clean up the front of the contact, and then I also need to use both hands, but I will bring you guys back when I have gotten this one solved. Okay, I think we may have figured out the problem, and I think we may have 2 more dead tubes, which is very interesting because tubes tend to be pretty resilient and don't need to be replaced this often. So, contrary to its late serial number and nice appearance, this meter may have a substantial amount of time on it, at least in the running position. So, what was happening was I was getting a little bit off. It was reading like 0.9, 0.8 volts on the 1 volt scale at full deflection. So I checked the range resistors, and they all checked out okay. Well, the 1 volt range resistor checked out okay. But then what I ended up finding is the 3 volt scale was off by the same amount. So the deflection at the end, if you were doing a full scale reading, was off, but by the same amount of deflection. So I checked the 10 volt scale as well, same thing. So I'm like, okay, my resistor ratios are right in the resistive divider on the range switch, because if the ratios weren't holding, the deflection would be different, and it wouldn't be staying in a relative deflection. So it's got to be something with the tubes, either the voltage amp or the bridge tube. Well, I haven't shown it yet, but over in the side of the lab, we have quite a few vacuum tubes, and I pulled some more 12 AU7s out of stock, tested about 3 or 4 of them, found a couple bad ones, popped those in my low bin, and they're all okay. They just test low emission. All fully functioning tubes, and they still test good on a good-bad test, but if you do a mutual conductance test, they're a little light on the mutual conductance. I happened to find, so I tested a bunch, because if I was going to replace both, I first swapped the two HP tubes, and that kept the same problems in the meter, so nothing really changed. But I also shot the switch with some contact cleaner, cleaned up the range switch, got a fresh tube that tested very strong for the voltage amplifier, but I also found a tube that was really well balanced on a mutual conductance test for the bridge circuit. So put that tube in for put the very well balanced one in for the bridge, put the amplifier tube in for the voltage amplifier, or put the well balanced triodes into the volt amp, and now we're deflecting over. So I have enough deflection back. Now I need to dial it out and then check some of the ranges. So with you guys off to the side and me straight on, and the meter has done its appropriate warm-up. We do have a volt coming out of the calibrator. And that right there is 1 volt precisely. This long tuning tool is perfect for adjusting this particular meter, because you actually have to get most of the way through the case to get to the controls. So, but we are good there, which is fantastic. Let's kick it up to the 3 volt range, and we'll bump it up to 3 volts. 2, 3. And there's 3.00002 volts. And so our 1 volt scale comes out here, but our 3 volt scale actually stops here, and it is dead on. That's where I kind of was talking about the ratio stability. Is you have to use this bottom scale for anything that ends in 3 with the appropriate multiplier, and you have to use this top scale for anything that ends in 1 with the appropriate multiplier. So just because, let's check the 10 and 30. Now, there are no calibrations for these. There are just, it's the resistor ratio stability, or ratio in the divider to make the scales line up. So we're going to go down to 1. We're going to go down to 0, 0, kick it up to the 100 volt scale, because that then puts us at 10. And we are at 10.00237 on the 7510, and we are very, very much right on the one. Let's check 30. And then bounce this up to 30. But as you can tell from the shadow being off on the camera's not straight on. But I'm also not at 30 volts either. That's a good 30 volts on the 7510. And it's, I will freely admit, it is way excessive to be comparing this meter to a 7.5 digit, this HP meter to a 7.5 digit modern meter. However, the HP is performing very well. Okay, I have everything set up to dial up the 1 volt AC. Now the scale I need to use for the 1 volt AC is down here, and we need to line it up with the 1 right there. So I've already got the tuning tool put in. I'm monitoring the 5200A with the 7510. I've got the 5200A phase locked to the 4192, which is then tied to the rubidium, so I'm getting the stability. And I'm also monitoring the 5200A with the Agilent 53131A, just to keep an eye on the clock, make sure it doesn't go too crazy. Please pardon the fan noise. I do have the 5205 on, which does generate actually a ton of heat and a bunch of fan noise. So, but I will need that for the 300 volt scale, so I need to get that warming up. But this is the 1 volt scale, so we'll tweak this. Now what I need to do here is I need to back the needle down. Nope, to other way. To right there. Okay, so next we're going to do the 3 volt range for AC. I need to bump the calibrator up to 3 volts, which I have to move this to the 10 volt range to do so. And bring this back down because I just slammed the needle. Didn't mean to do that. 3 volts. 997. 999. A little bit more. Little bit more gas. The range switches on the front of my 5200A are very fiddly, so I don't necessarily care what the range switches are. I'm comparing them to the 7510 and using the 7510 as a transfer standard to bring its accuracy down to the 410B. So the 3 volt range is reading a little hot. So we'll bring that down because I need to bring the 3 volt range down to there. Now I'll move the camera out of the way, do it straight on the meter, and then that'll cal that range. Okay, next up is our 10 volt range. Let me tweak the 5200. Spin this up to 10 volts. Right there. 10.006. Let's see if we can back it off a bit. $10 with 4 zeros. I'll take that. That won't be a problem. Now we're back to the 1 volt range, so we need to adjust for up top. So this actually needs to come up to right about there. Again, same procedure. Calibrating the meter straight on, and then we'll move to the 30 volt range. Now the 30 volt range potentiometers are in the side of the unit, so I'll have to back it off of the case a little bit to do the 3000 and 300 volt range. And the 30 volt range is out a bit too, not surprising given the tube change, but we'll get right in here, bring this up to and there we go, good for the 3 volt range. So I need to redo the 3 and the 10 volt range because I just realized I forgot a step. So I'm going to redo those after I put it back in the case. I didn't set the AC 0 in between each calibration range, and I should have been doing that. So I will need to 1 volt range was fine, 30 volt range is fine because I did set the 0. 10 and 3 volt ranges need to be done. The other thing that I'm going to do is for the 300 volt range and the 100 volt range, I'm going to exercise these controls. A lot of that meter bouncing around was because the controls hadn't been exercised in a while. I don't want to bang around the needle if I don't have to. So having exercised the controls, and if they're still scratchy, I'll get a little cleaner and hit it in there and do that. But next up is the 1 volt range, or the 100 volt range. So we'll do this and see how the meter's off just a touch. We want to 0 the meter on the AC range, and there we go. So now that I'm getting 100 volts AC at 100 hertz, this is starting to get into the spicy voltage territory. So I'm going to start being really careful on the bench and getting into treating this as high voltage. Anything really over 50-ish volts, I treat everything the same as if it's 10,000 volts. So it's just something that I've done for a long time, getting into the safety of things, and it's served me well in the past, but I need to crank the 5200A up to 100 volts. There's 100 with 3 zeros, so I'll take that. So yeah, the 100 volts is off. I need to align that. Now that the 100 volt range is done, obviously the needle tanked all the way down to the bottom again. That's because I turned the source off before I did anything with the voltages, because I now need to hook up the 300 volts and set that up. So I definitely do not want to be handling this stuff when I'm fiddling around with 300 volts. And for those that don't know, while I hook this up and the source is off and everything, the 5205 is nothing to mess with. It's a 100x amplifier. So whatever the input source is, it will, whatever signal you put in the front end, it'll output 100 times greater. And the crazy thing about that is it can go up to 1500 volts AC at 10 kilohertz. So it definitely has the potential to be spicy. So if you are following along, you are doing so definitely at your own risk, and take extreme care, because sometimes this stuff gives you zero chances. And also remember, we're working with voltages that can not only hurt me or another technician, we're also working with voltages that could definitely hurt the test equipment too. So I want to be very careful when I switch this stuff on. Okay, had a bit of trouble with the 5205. It didn't like phase lock being turned on the 5200A. It wouldn't actually online, but it's onlining now, so we can get this alignment done. So we'll kick this into operate, and there we go. We have a bad meter connection because didn't have my right leads hooked up, so that's not going to measure correctly at all. So shut it down again, put these leads on, and now let's hit operate. Survey says, there we go, now it's reading right. The meter was only telling me it was at 60 something volts AC when I'm outputting like 300, so there was no way. All right, yep, that's good enough for 300, 300. We will line this up being extremely careful of the spicy on the desk. Okay, and I did confirm the 0. And our big amp's on, so now we let it stabilize. Yep, 300 volts. Come in here, like so. Put this right there on the 3, and that is actually perfect. Okay, so for the ohms position, we need to 0 set on the 10 volt range. And it's probably going to need adjustment. So set for infinity. Go back to the 1 volt range. If it's off, set the potentiometer on the back of the unit. Do this a couple times, and the ohms range is adjusted. So time for me to do that. And there we are, zeroed on the 1 volt range. Thanks for stopping by the lab and taking a look at the restoration of this HP410B. This unit's now ready for the bench, and we'll find a home somewhere around the lab. I had some weird faults in this one. I wasn't expecting to have to replace 3 tubes when I got started with this one, but it's how it goes sometimes. So, if anybody has any questions, comments, anything interesting, leave it in the description below. Comments below. I read all the comments of the videos. And as always, more's on the way, and I will see everybody in the next video.